everyone, welcome back to Pepcoding. So the question which we are going to talk about today is called two stacks in an array. Let us discuss the question first and then we'll head over to the solution. So let me bring the question statement as well as the constraints to the board and then we'll talk about it. Okay, here we have the constraints. Okay, so what we are told in this question is that we have an array. Okay. Suppose we have an array. Let me draw a straight line first. Okay. So using this array, I need to create the functionalities of two stacks. So 1, 2, 3, 4, and 5. Okay. Let me say that the capacity of the stack which I am taking is 5. Okay. So 0, 1, 2, 3, 4. Now what I am told is that I need to take the functions, that is push 1, push 2, pop 1, pop 2, top 1, top 2, and size 1, size 2. That is push, pop, top, and size for stack 1 and push, pop, top, and size for stack 2 as well. All these I have to make using an array. Okay. Also, I've been told that the memory should be used optimally. Okay, that means that we will only return overflow when the entire array is fulfilled. If there's any place in the array which is remaining, that is, we have any empty space in the array, we will fill it irrespective of whether it is used by stack 1 or stack 2, and we have to manage those cases. But if I have a condition where the array is completely full, then and only then I'll print stack overflow. Also, I need to make sure that all the functions should be in constant time. Okay, so we'll work on these. You know what these functions do, so we are not going to talk a lot in detail about them. We'll directly talk about these functions for this question, that is two stacks in an array. So see, I take over here. This is the array itself. Okay, so I have the array over here. I have 1, 2, 3, 4, 5. Let's say I just want 5 elements. Okay, so with these 5 elements I'll be working. The positions will be 0, 1, 2, 3, and 4. So when I work with a single stack, I know that I have a pointer or top of stack, and it is always at -1, denoting that the stack is empty. Now what I'm doing is I want to work with two stacks, right? So one top of stack will always lie over here only, that is -1. The second top of stack, I am saying this is 1. I am saying the second top of stack should be put at the position which is equal to the length, total length of the array. That is, if I have, see, the index which I have at the end is 4, right? And the length of the array is 5. So I'm saying that I'll put top of stack 2 at 5. That is the length of the array. Okay. So this is what my top of stack 2 will be. So if I'll say push 1, 10. So over here I'll have 10. How? Top of stack 1 will increase by 1. If I say push 2, 10. So top of stack 2 will decrease by 1, right? From 5 it will go to 4. I have 10 over here. Then I say push 1, 20. Again top of stack 1 will increase. It will come over here. And I have 20 here. Then I say push 2, 20. I get 20 over here. Top of stack again decreases by 1. Then I say push 1, 30. Okay, this increases, comes over here, and 30 comes here. So over here I have top of stack 1, over here I have top of stack 2 currently, right? I'll remove all this. It will, let's keep this over here so you know that top of stack 1 will start from here. So currently I have these positions. Now here if I say push 230, can I do that? No, right? Because the array is complete. It is full. Now I cannot push any other element until I pop. So the condition becomes that, see, top of stack 2 is lying at top of stack 1 plus 1 position. That is, over here it is 2. Top of stack 1 is at 2 and top of stack 2 is at 3. So this is how push function will work, that we will print overflow when top of stack 2 is lying at top of stack 1 plus 1. Otherwise it will go normally. So let's first try to write this. So over here for push 1, I will say that if top of stack 2 is equal to top of stack 1 plus 1, in that case print stack overflow and return. Okay. Otherwise what we'll do is that we will push the value onto the stack. So on self dot top of stack 1, since I am pushing onto the first stack, so on top of stack 1 position of data array, I'll push val. Okay. Also, 1 second. Okay. Also what happens is that I want the top of stack 1 to increase by 1, right? It is lying at -1. If I want to push an element, I want it to go to 0, so it will increase by 1. So top of stack 1 will increase by 1, right? Then when it comes to push 2, this condition will remain the same. There's no change. Over here, I'll have 1 second. Yeah, here I'll take this condition only. Then the second thing is that otherwise top of stack 2 decreases by 1, right? I am lying at the position which is equal to the length of array. I want to go to the last index, so I want to decrease it by 1, and I'll put the value onto the array. So cell.data at toss2 position, I'll put the value. Now see, I have not completed these functions, so I need to initialize the data array top of stack 1, top of stack 2. So top of stack 1 I have put at -1. Top of stack 2 I have put at, where did I put it? At capacity, right? That is, if I say that my maximum capacity is equal to 5, then I will put it at 5th position, because the array only ranges from 0 to 4 in this case, right? So I will take this condition over here. It will become equal to capacity. And the next thing which I am working with is my data array, that you know how to initialize into. Okay. Then size. You know how the size is returned in stacks, right? So the size of a stack is obviously, it means that the number of elements which are present in a stack, and it is equal to top of stack plus 1. So we'll, for the first stack we are working from the bottom only normally, so it will simply return self dot top of stack 1 plus 1. There's no problem in this. Then when we are working with the second stack, see, over here I have the second stack. So I have 10, 20 and 30. So if this had total capacity as 6, so earlier top of stack 2 was at 6. Now it is 5, 4 and 3. So when it came to 5, the size became 1, right? Earlier it was 0. When it came to 4, size became 2. When it came to 3, size became 3. So I can see that's 6 minus 5. The size is 1. 6 minus 4, size is 2. 6 minus 3, size is 3. So what we can see is that the size of the second stack is returned by, 1 second, we'll go here. To return length of data array, right? And from that we'll subtract the value of top of stack 2. So we will get the size. Okay, so now we worked with the size functions as well as the push functions. Now we need to work, let's talk about the top of stack. Like how we will get the values from the top. Okay, so it's not that difficult. We know that if top of stack 1 will be equal to -1, then we cannot return any value. So we will first write that condition, right? That if top of stack 1, we need to write self dot is equal to -1, then we'll simply print stack underflow, right? 1 second. And what do we return? -1. Otherwise, what do we do? If I have an element, if I have an element available, I'll simply return that element. Return self.data and the position, right? Self.top of stack 1. Not that difficult. Then if I am working with top of, like for the stack 2, then in this case, top of stack 2, when will it be empty? When I know that the top of stack variable is lying at the position which is equal to the length of the array. So when it is equal to the length of data array, it means that it is empty right now. So we'll print stack underflow and we'll return -1. Okay. Otherwise, what we'll do? We'll again return self.data, self.top of stack 2. So top was not that difficult. Now when we are working with pop, there's not much difference to make, but a little has to be done. So see, when we are working with pop, the underflow condition remains the same. But when I have over here values as 10, 20, 10 and 20. So top of stack 2 is here, top of stack 1 is here. I say pop 1. When I say pop 1, I need to decrement top of stack by 1, right? So first we'll work with for 1. So what I'll do is, I cannot directly return this value, right? I need to store it somewhere first. So over here, I'll take a variable name, any name you want. I'm taking NV. And in this, I'm storing the value which is present at the top of stack, right? And I decrease top of stack by 1. So self.top of stack 1 will be decreased by 1 and we'll return NV. And when we are working with top of stack 2, that is the second stack, if I want to pop this element, I say pop 2. Top of stack 2 needs to go up, right? We have 0, 1. Suppose here was an element, any element, or it is empty, right? And I have 4 over. So from 3, I need to go to 4. So in that case, what I'll do is top of stack 2 will increase by 2. So I'll copy this. Okay. Paste it over here. We cannot directly return, like we just talked about it, right? So we will first store the value somewhere. I'm taking it in NV, self.data and self.top of stack 2. And top of stack 2 will increase by 1 and we'll return NV. So we've completed the functions. Now let us try to run this code and we'll see. We have, okay. So, okay, in line 49, I made a mistake. Line number 49, I did not write self. Now let's try. Okay, this is accepted. So we are going to submit this. and it is the correct answer. So we discussed about 2 stacks in an array in this question. I hope you understood the question as well as the solution, and thank you for watching the video. We'll see each other in the next video. Till then, like, share and subscribe to the channel.